of y equals ax, that thing, is called a, what's happening here, parabola. Okay, and every graph has a minimum or maximum. We're going to talk about this next time. It's called a vertex, and we did talk about the idea of a vertex when we did the lesson 3 on maximum and minimum values of things like ticket sales or t-shirt sales, right? Okay, I want us to also notice that the graph is symmetric. So what that means is when I have a parabola, I can actually find a line where if I fold this in half, it would fold on top of each other. Okay, so in this case, it's called an axis of symmetry. I'm going to have to scroll up here to show you. What I want us to do is talk about the vertex of this guy. So the vertex that we have here has a coordinate. Okay, so in this case, it's 0, 0. And as you can imagine, the vertex changes as this parabola moves side to side and up and down. Okay, also, if I want to define the line across which this is symmetric, I can see that it's actually the vertical line x equals 0. Okay, so in this case, it's x equals 0. Okay, we're going to get into more detail after we do a little bit of graphing. Okay, so now what I want us to do is, I know there are a number of ways to graph parabolas. I know some of you already know some of these ways. But what I want us to do while we're in this lesson and in this unit is I want us to use 5-point mapping. So very similar to what we did at the start of this lesson, what I want us to do is start by using our 5 important points. Okay, and actually, we can squeeze in the negative, you can squeeze in the 9. Okay, so we've got 3, 9 and negative 3, 9. We've got 2, 4 and negative 2, 4. Negative 2, 4. Negative 1, 1, 1, 0, 0. Okay, so this is my first graph, which of course is horrible. I'm even worse on the iPad than I am on the board somehow. Okay, and then what we want to do, if we want to translate this, we can see pretty clearly actually that h is 3, meaning 3 units to the right. Don't forget, okay, this is positive 3, not negative 3. And k is negative 4, meaning 4 units down. Okay, so what I'm going to do is take each of these. Let's start with the vertex, actually. We can go 3 units right and 4 units down. Okay, 3 units right and 4 units down. 3 units right, 4 units down, and you get the idea. And because in this case we have the same shape, right, we can actually make sure, okay, 1, 2, 3, 1, 2, 3, 4. We can actually make sure it looks right by judging from the vertex. If I go 3 across, I should be going 9 up, right? If I go 3 back, I should be going 9 up. Let's just make sure. 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. So we have a couple of questions we need to answer. Okay, so what I want to know is, what is the vertex? Well, the vertex is right here. The vertex is at 3, negative 4. And what you'll notice is that the vertex has a relationship between with the translation of the function. Same with the axis of symmetry. The axis of symmetry for our parent function, or the original function, we know is x equals 0. But for this guy, we know that it's got to go through the vertex, right?
So the equation of this axis of symmetry is x equals 3. And when we write it in our table, we don't want to just write it as 3. We're going to write it as the equation of the line x equals 3. For the domain of this parabola is the same as the domain of every parabola, and that is negative infinity to infinity. I'm probably going to stop asking that question soon. Now, what about the range? Well, if we look at the parabola, we can see that the minimum value of the parabola is the vertex, and then it goes all the way up to infinity. So our range is going to include the bottom value, that minimum value of the vertex. So the lowest point of my parabola is -4, and then it reaches all the way up to infinity. So what I'd like for you guys to do now is please try the next one on your own, and pause the video and then look at it when you're done to see if it matches up with my answer.
All right, guys, so hopefully you got the same answer as I did. I just have one more thing to go over for this lesson, and that is the following. I don't actually need a graph to do this, and in fact, I'm going to encourage later that we don't do it using a graph. So what we can do instead is we can use the mapping like I showed you in the first part of this lesson. So what I'd like to do is create a table with 4 columns, okay? And then I'd really like to start with that -3 in my x, -3, -2, -1, 0, 1, 2, 3. Most other teachers just start here at -2, and that's fine as well. So what I need to recognize here is that h is 77, right? It's not -77. So I'm going 77 units to the right. Okay, and I know that k is 89, meaning 89 units up. So what I'm going to do in my table is I'm going to make sure that I add 89 to all of my y values, and that I add 77 to all of my x values, and that's about it, right? So here we go. We've got 98, 93, 90. You'll always see that there should be some symmetry in your y values. Okay, that's why it's symmetric, is because of the y values. Okay, and with the x values, 74, 75. Okay, so I mean, I could now give you something to graph, and you would know that in your graph you're going to start way out here at 70, probably 77. You're going to plot 77, 98, and etc. Sorry, 77, 89. And then you would draw your parabola here. Anyway, we don't have to do that. What I'd like us to do, though, is write down the vertex, which is 77, 89. I know that the axis of symmetry is going to be x equals 77, right? The domain, -infinity to infinity. The range is 77 to infinity. And there we go. So again, I'd like you to pause the video, give this one a shot, and actually we can just do a quick summary now. Okay, so in summary, the graph is called a parabola. Every parabola has a minimum or a maximum called a vertex. It has coordinate value of hk. Beware of the sign of h. The parameters h and k translate either left or right or up and down. Again, beware of the sign of h. The graph is symmetric when folded in half vertically about the line x equals k, and that line is called the axis of symmetry. Every parabola has domain -infinity to infinity, and I'd like to save my comments on the range until next time because we still have to learn one more thing.